In this video tutorial, I am going to do my best. I'm going to try my best to explain to you what we mean or what I mean by solving linear equations. Okay, so this is appropriate for GCSE 91 maths, higher foundation, key stage 3 maths, 11 plus maths, 13 plus maths, and potentially, functional skills. I think level 2 only for all the examples. Okay, but obviously check on it if you're not sure. Okay, so please remember. So the word solve in maths means to find the value of the variable here. So find the variable. Okay, so variable could be x, y, z, p, q, r. Okay, a, b, c. So what the number actually represents. Okay, the inverse. This is actually key here. So the inverse of plus and minus. Sorry, plus is minus. And the inverse of timesing is dividing. Okay, all times dividing. Work out one step at a time, keeping you equal signs in line on each new row of work. Yeah, okay. So so the key takeaway is as follows. Whatever I do to one side, I must do the exact same to the other side to keep it in check. So to keep it in balance. Okay. So if I take away 2 on the left side, I do take away 2 on the right side. Okay. If I times by 4 on the left side, I times by 4 on the right side. Okay. If I divide by 10 on the left side, I divide by 10 on the right side. Okay. So question number 1. So a two-step function machine is shown. We got input times 3 and then add 4 and then there's our output. Okay, and we always follow it in the order. Okay, so we times by 3 first and then we add 4. Part A, when the input is minus 4, what is the output? We got input of minus 4. So minus 4 times 3 is minus 12. Minus 12 plus 4 makes minus 8 or negative 8. Okay, when the input is minus 4, the output is minus 8. Okay, according to this function machine. Okay, part B, if the output is 25, what was the input? Again, we're actually going to obviously working backwards. Okay, so you're giving the final answer. So this time I'm obviously going backwards. What's the opposite of adding 4? That would be to take away 4 or subtract 4. We do 25, take away 4 first. Okay, which is 21. And then the last step now is, what's the opposite of times by 3, guys? That'll be to divide by 3. So 21 divided by 3, okay, will give us 7. Okay, so the input, okay, when the output is 25 is 7. And again, if you're unsure, obviously check it by going up here, the forward way. 7 times 3 is 21. 21 plus 4 does indeed make 25. Okay, what about part C? If the input is n to n, just number here, just a letter, what is the output? So I do n times 3, then I subtract 4. Okay, now n times 3 in algebra, I can rewrite this as just 3n. Okay, without the actual times. Okay, got 3n minus 4. So the output when we got n is 3n minus 4. Okay, it takes the number n, it multiplies by 3, hence 3n, then it subtracts 4. Okay, so this is what I call my general algebraic expression. Okay, so if n is equal to 1, I do 3 times 1 or 1 times 3, which is 3, then I minus 4 and I get minus 1. Okay, so this is a generic algebraic expression for the input n, my output of n. Okay, right, question number 3. Okay, part A, solve 6g equals 18. Now 6g means 6 times g. What's the opposite of timesing, guys? That'll be to divide. So we divide, both sides by 6. Okay, divide by 6. We have g equals 18 divided by 6, which is 3. Okay, and I can check. 6 times 3 is 18. Okay, so that is right. Okay, 100%. Next one, part B. Solve 5h plus 7 equals 17. Step 1, I'm going to subtract that 7 first. Okay, on both sides to keep each side in check, to keep each side balanced. Okay, we have 5h is equal to 10. I don't want 5h, I just want h. So I'm going to obviously divide by 5 on both sides to balance each side of my equation respectively. H equals 10 divided by 5, which is 2. Okay, and if I'm unsure, I can check. 5 times 2 is 10. 7 makes 7. Yep, so that is indeed correct. For A, solve x plus 9 equals 19. I'm going to subtract 9 on both sides. Okay, obviously x here by itself. We have x equals 19, take 9 is 10. So 19 minus 9 is 10. 19 subtract 9 is 10. Part B, solve 2y equals 17. Okay, so y will equal to 17 divided by 2. Okay, which I can simplify here. Right at the mixed number, that'll be 8.5 or 8.5. Okay, again, particularly at A-level maths, guys, get in the habit of leaving your answers in exact form. Okay, avoid where possible. Okay, not always, but avoid where possible giving your answer as a decimal. Okay, it is fine, obviously, for example, to leave it as an even fraction. Okay, or a mixed number. Okay, unless obviously obviously state obviously, otherwise that's fine. Okay, but get in the habit, okay, if it doesn't go in fully, then just leave it as an improper fraction or a top end fraction. Okay, that is my advice. Okay, part C, solve W over 4 equals 8, so W quarters equals 8. Remember that line obviously means division. Okay, what's the opposite of dividing, guys? That'll be the times. So times it by 4, times it by 4. We have W equals 8 lots of 4. 8 times 4 is 32. And again, I can check it. 32 divided by 4. Okay, remember that obviously line means fraction. 32 quarters, 32 divided by 4 gives us 8. Okay, so we are indeed correct. Question number 5a, solve n sevenths equals 2. So n over 7 equals 2. Again, that fraction line means a division. So I'm going to times by 7 here on both sides to isolate, and get n by itself. Okay, so we have n equals 2 times 7, 2 lots of 7, guys, and we get 14. So n is equal to 14. Okay, part B, solve 3g plus 4 equals 19. Step 1, I'm going to subtract 4 on both sides. Okay, balance each side here respectively. You have 3g is equal to 15. Okay, so 19 take 4 is 15. I don't want 3g here, I just want g. So I'm going to divide it by 3 on both sides. When I do that, guys, we get g equals 15 divided by 3. So 15 over 3, 15 thirds, we get g is equal to 5. And that, guys, is my final answer, okay? And that concludes today's video on solving 1 and 2 step linear equations for GCSE 91 Maths, Higher and Foundation, okay? Thanks for watching. Take care. All the best, okay? Drop your topic requests below in the comment section of TikTok, Instagram, Facebook, or YouTube, and I'll try and make a video on your chosen topic. Okay? Bye for now, okay? Happy Friday, okay? Happy weekend.